The small shop owner has bought in the Santa or in any right bazaar.
Those type of plastics are known as thermosetting plastics. Comparison, there are 3 types.
Up, down, right, left.
I am not inferior to anyone.
We are TSWREIS. We are top on the Everest. Congratulations.
I want to be a leader.
Hi TSWREIS. I am Deeksha from second year BPC. So friends, today we are very happy now. So okay friends, let me start. So in your previous classes, you learned so many things. What friends? Yes, the molecular formula is same, the structure is same. The molecular structure is different, the molecular formula is different. So friends, here this is the difficult. What? The molecular formula is the same, but that are structurally different in some way. And it is able to recognize the different types of isomers. So friends, it is how it's possible. So friends, here, do the compound have same molecular formula, but that are structurally different in some way, and it is able to recognize the different types of isomers. So friends, it is possible. So let's discuss about what. So friends, you know already mother. What is the meaning of mother friends? So here in mother means we call in English mother. So in Hindi we call ma. In Telugu we call amma. In Marathi we call I. So friends, these are all mother is one, but we called different languages. Okay friends, are you following me? Okay TSWREIS. So for here, this same way we call mother in the different languages, but here the molecular compound that have the same molecular formula, but that are structurally different in some way, and it is able to recognize the different types of isomers. Am I right friends? So okay friends. So isomerism. So first of all, what is the isomers? Yes, isomers is nothing but isomers are compound that have the same molecular formula, but that is structurally different in some way. So these phenomenon is called as the isomerism. So next we see the isomerism. So friends, here the compound that have the same molecular formula but having different properties are called isomers, and phenomenon is called as isomerism. Okay friends, are you sure? Okay, so compound with the same molecular formula but having the different properties and called as isomers, and that phenomenon is called as isomerism. So friends, here this is the structure of isomers. Okay friends, are you following or not? So this is the structure of isomer 1 and this is the structure of isomer 2. So friends, you are eagerly waiting for, so it is possible or not? Do the compound have same molecular formula but that are structurally different in some way, and it is able to recognize the different types of isomers. Are you sure? Okay friend. So here structure of isomers. So what is the meaning of isomerism? So let me see the slides. Compound that have the same molecular formula but that are structurally different in some way, and it is able to recognize the different types of isomers because they can have the different properties, chemical, physical properties and biological properties. So this is the isomerism. Are you sure friends? Here this is the possible friends. What? Do the compound have same molecular formula but that are structurally different in some way, and it is able to recognize the different types of isomers. What? Chemical, physical properties and biological properties. So this is the isomerism. So friends, I will show what isomers are nothing but that are compound that have the same molecular formula but structure is different. So friends, let me discuss about, do the compound have same molecular formula? Yes, exactly. You are very brilliant TSWREIS. What in? Isomers. Okay friends. So here the compound that have same molecular formula but that are structurally different in some way, and it is able to recognize the different types of isomers. So friends, here do the compound have same molecular formula? So friends, now we are discuss isomerism. Isomerism are classified into two types. Okay friends, here do the compound have same molecular formula but structure is different. So here the isomers are classified into two types. What are they? Yes, very good Saros. Configurational isomerism and conformational isomerism. Okay friends, here do the compound have same molecular formula? This is the isomerism. Do the compound have same connectivity? Yes, the conformational. So here the conformational isomerism again classified into two types. What are they friends? Yes, here geometrical isomerism and optical isomerism. Am I right friends? Okay Swaros, here isomerism is nothing but commonly that compound have same molecular formula but that are structurally different in some way. And here the compound that has same connectivity, what? Configurational and conformational. So friends, here classification of isomerism. What? The classification of isomerism divides into two types, constitutional isomerism and stereoisomerism. So here friends, what? Last one is again classified into two types, configurational isomerism and conformational isomerism. So here the conformational have same connectivity. Yes, right? Yes, the conformational have same connectivity. So that's why they are called divides into two types. What are they? Optical and next one is, yes, exactly Sparrows. Next one is geometrical isomerism. Are you sure friends? Yes, here the same have connectivity to the products of interconverted by the double bond. So here friends, the conformational isomerism classified into two types. Okay friends, optical and geometrical. Okay friends, are you eagerly waiting for what is possible? What friends? Yes, it is, do the compound have same molecular formula but structure is different. So how it is possible? So let me see what is the geometrical isomerism. So today we are discuss about what? Yes, I know friends, you are very intelligent. Okay, so let's we discuss about geometrical isomerism. Okay, Cyrus, are you following me? Okay, the geometrical isomerism. Already you know what is the isomers and what is the isomerism. So let me see what is the definition of geometrical isomerism. So the geometrical isomerism is the nothing but these are spatial arrangements, means these are the molecules and they arranged with the spatial that movements is called, and the double bond or a ring structure is called as geometrical isomerism. Okay friends, geometrical isomerism is the nothing but geometrical isomers are molecules that are locked into their spatial position with respect to one another due to double bond or a ring structure is called as the geometrical isomerism. Are you following Sparrows? So okay, so this is the geometrical isomerism. In this geometrical isomerism friends, we observe what? Here the double bond and this is not rotated, commonly excited by the alkanes, the presence of two different non-superimposed possibles. Okay friends, this is the definition of geometrical isomerism. So friends, what is the structure? Already I can you get the idea. So types of isomerism. Types of isomerism. So here the isomers are classified into again two types. What are they? Yes, structural isomerism and yes, where was exactly stereo isomerism. So here these the compound have same connectivity. So here the stereo again classified into what? Yes, here the structural isomerism again classified into, yes, whereas you are very brilliant, I know. Yes, what are they? Optical isomerism, chain isomerism, position isomerism, and last one is, yes, functional isomerism. Here the stereo isomerism again classified into, yes, two types. What are they? Optical isomerism and geometrical isomerism. Okay, Sparrows? Here the isomers have the same connectivity. To the stereo isomerism and structural isomerisms, the structural isomerism classified into three types. What are they? Chain isomerism, position isomerism and functional isomerism. So let me see this slide. So the stereoisomerism classified into again two types. What are they? Optical isomerism and stereoisomerism. So I know friends, you are eagerly waiting for what is the definitions of these and what is the examples of these terms. So while let me discuss about what is the examples. So first, chain. So friends, you know what is the definition of chain isomerism here? The chain isomerism is the nothing but it is the position. So it converts to in the molecules can be rearranged to give and branched carbon chains. And coming off the main chain, the position of the carbonate chains and name of the molecule changes to reflect the new position is called as the chain isomerism. Okay friends, so let me watch this slide. What? The position of the molecule carbon atoms in the molecule can be rearranged to give and branched carbon chains coming off the main chain. The name of the molecule changes to reflect this, but the molecular formula is still the same. So this is the real, you can identify this and you can must and should concentrate on this double bond. Okay friends, okay, here the chain isomer is nothing but the position. Okay friends, the position in the molecule atoms, the molecule rearrange to give and branched carbon chains and coming off the main chain, but the name of the molecule changes to reflect this, but the molecular formula is still the same. Yes friends, exactly. So what is the example of this? Let me see. So you know friends, you are very intelligent in chemistry. C4H8, C4H10. First we take C4H10. What is the molecular formula? For first we take structure. How many carbons are there? 1, 2, 3, 4. 4 carbons are there. How many hydrogens are there? Yes, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the position of the molecule changes to rearrange to give and branch the carbon chains and coming off the main chain, but the name of the molecule changes and position in the molecule changes to reflect this, but the molecular formula is still the same. So what is the name of this structure friends? Yes, this is the butane. Oh, you are very talented sirs. So here the molecule formula is still the same. How can it converts? So let me see here. The butane, what is the molecular formula here? Yes, C4H10. So it converts to what? Let me see here. 1, 2, 3, 4. 4 carbons here? Yes. How many hydrogens? 10 hydrogens. So let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, first we can go the first definition. Here the molecular formula still the same. But here the structure, we can change only structure. Here means butane converts to what? Yes, 2-methyl propane. Means it's when the rearranged to carbon atoms, it reflect the new, but the molecular formula is still the same. We can observe this C4H10, C4H10, but we can change the structure. Okay friends, this is formula of butane. So C4H10. So what is the structure of it? Let me see here. The structure of butane, how many carbons are there? 4 carbons. And how many hydrogens are there? Yes, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's right. So butane converts to what? Let me see here. Formula of 2-methyl propane C4H10. The molecular formula still the same, but structure is different. How? Let me see here. Structure of 2-methyl propane. So what is the structure of it? Yes. How many carbons are there? 4 carbons. How many hydrogens are there? 10. Exact correct. So here 4 carbons, 10 hydrogen. So here what is the name of the structure? 2-methyl propane. So very good friend. So this is the chain. Okay friends, are you understood? Okay. So what is the next? Yes, that is the position isomerism. So what is the definition of that? The molecular formula. Okay friends, the molecular formula remains the same. The type of the functional groups also remains the same, but it reflects to the new. What? Let me see what is the definition of position. The molecular formula remains the same. The type of the functional groups also remains the same, but its position in the molecule changes and the name of the molecule changes to reflect the new position of the functional group. Are you sure? So, what is the definition? What is the structure of this? This is the position isomerism. Are you sure, friends? So, next we see formula of butene. So, what is the chemical formula butene? C4H8. So, this is the molecular formula of butene. So, what is the structure of it? So, this is the molecular formula of butene. So, this is the structure of butene. So, what? How many carbons are there? 1, 2, 3, 4. How many hydrogens are there? 8. So, 1, 2, 3, 4, 5, 6, 7, 8. Okay, friends. Here the 8 carbons are there. So, this is the structure of what? Yes, butene. So, friends, here butene converts to what? 4 carbons. How many hydrogens? 8. 1, 2, 3, 4, 5, 6, 7 and 8. So, here why we call the butene here, friends? Let me see here the butene means we can put double bond in front of second carbon. That is why we call the butene exactly. So, butene converts to what? So, once again this is the molecular formula is C4H8. So, structure of the butanene. So, here the butanene converts to what? Structure of butanene. So, 2ene converts to 1ene. So, why we call the butanene here? Yes, then we can put double bond in front of first bond. That is why we call butanene. So, here this is the position. So, last one is functional isomerism. Okay, friends. Here this is the functional isomerism. So, what is the definition of it? Let us watch its slide. So, these isomers also refer to functional group isomerism. These isomers have the same molecular formula, but atoms are rearranged to give a different functional group. The name of the molecule changes to reflect the new functional groups. Okay, friends. So, here this is the definition of functional isomerism. So, structure of butane. Already you know what is the structure of butane. What is the formula of C4H8? So, C4H8, this is structure of C4H8. So, why we call butene? Already you know. Why we call the butene here? We can put double bond in front of second carbon. That is why we call the butene. Okay, friends? Okay, are you following me? This is the formula of C4H8 into butene. So, here butene converts to what? Cyclobutane. How it is possible? Possible. 1, 2, 3, 4. 4 carbons are here. And how many hydrogens are there? 8. So, let us count it. 1, 2, 3, 4, 5, 6, 7, 8. Am I right? Yes. Here the C4H8. What is the first we can go the definition? What? It refers also the same molecular formula, but that structure is different and it is able to recognize the properties also. Means here butene converts to what? Yes, cyclobutane. This is structure of cyclobutane. Okay, friends. So, next this is the molecular formula of what? C4H8. So, here this is the structure of cyclobutane. Are you sure, friends? And another structure of cyclobutane, same molecular formula, structure is different. So, this is the structure of cyclobutane. Okay, friends? Okay. So, geometric isomerism. So, we must and concentrate on this because this is the very important. Okay, friends? Are you sure? So, this is the structural isomerisms in types. So, friends, the geometrical isomerism. So, already I will tell what it is the possible, not it is the possible. What? The double bond change to what? Let me see. I know you are eagerly waiting for geometrical isomerism because we discuss about geometrical isomerism. So, friends, here geometrical isomerism is nothing but here commonly excited by the alkanes the presence of two different substituents on both carbon atoms, but at either end of the double bond it can give rise to two non-superimposable isomers because they can restrict the rotation of the bond, right. So, here the geometrical isomerism is nothing but geometrical isomers is nothing but commonly excited by the alkanes, the presence of two different substituents on both carbon atoms, but at either double bond, it can give rise to two different non-superimposable isomers because they can have the restricted rotation of the bond. So, let me watch this right. So, what is the definition of it? Commonly excited by alkanes, the presence of two different substituents on both carbon atoms. At either end of the double bond, it can give rise to two different non-superimposable isomers due to the restricted rotation of the bond. This is called as geometrical isomerism. Okay, friends? Okay, what is the structure? What is the name of the structure, friends? Here, this is the 1,2-dichloroethane. 1,2-dichloroethane. So, what is the molecular formula, Sparrows, here? C2H2Cl2. Are you sure? So, let us watch it. What? C double bond C and single bond chlorine, chlorine, hydrogen, hydrogens. Are you following, Sparrows? Okay. So, here this is the formula of 1,2-dichloroethane. So, friends, here what is the 1,2-dichloroethane structure? So, it converts to what? So, this is also, yes, exactly, this is also 1,2-dichloroethane. How it is possible? So, let me see, we can, okay friends, this is the 1,2-dichloroethane structure. We change to what? Yes, how it is possible, friends? Already I will show now. This is the possible what? In geometrical isomerism, this is the possible. They have the restricted rotation of the bond and commonly exhibited by the alkanes, the presence of two different non-superimposable isomers. Because they can have the restricted rotation of the bond, automatically they are not rotated, but they have the different types of properties. Am I right? Okay, Sparrows. Here 1,2-dichloroethane converts to 1,2-dichloroethane. So, anything observe here right? Okay, friends. Cis isomerism. Actually, this is the new now. So, what is the cis isomerism, friends? So, let me discuss about cis. Means, no, this is, you can not go. Here the not completed. You can observe this and you note it. What is the, what we can observe this 2. So, here the 1,2-dichloroethane converts to 1,2-dichloroethane. In the, we can go to the front, means the position, what? But-2-ene converts to but-1-ene. 2-methylpropane converts to cyclobutane. So, we can change to all the structures, but here the geometrical isomerism is different now. So, that is the matter. So, here you can observe anything here. So, what is that? Yes, cis isomerism. So, here what is the cis and what is the trans, friends? Cis is the nothing but, okay, this is the cis. What? Here, you can watch this, friends. Here the cis is the nothing but which have the same side. You can watch the slide also. So, which have hydrogens are one side, chlorines are one side. So, what is that? Yes, which have the same side is called as cis and which is the opposite side are called trans. Wow, you can get my point. Okay, friends. So, this is the trans isomerism. What? Already I will say which is the same side is called cis and which is the opposite side are called trans. Means here the chlorine one side, hydrogens are one side. So, this is the, yes, exactly, this is the cis. And chlorines opposite side means across and here hydrogens are opposite side. So, what is this? Yes, this is the trans. So, friends, what is the difference between cis and trans? Means the nothing but here the cis is which have the same side. Okay, friends, are you following me? Okay. So, which have the same side is called the cis and which is the across, which means here which is the opposite to called as trans isomerism. So, cis and trans. So, first slide cis means the green. Okay, friends, the green colors are one side means there is the cis and down trans. So, here the across and opposite side are called trans. So, another example of cis and trans. So, are you sure? Okay, friends. So, this is the structure of 1,2-dichloroethane in cis. So, already you can see here across means this is the opposite side called as trans and which is the same side we called as yes, cis. So, this is the structure of cis and trans 2-butene. Okay, friends. How many carbons are there? 1, 2, 3, 4 and how many hydrogens are there? 8. So, which have the same side is called as cis and which is the opposite side are called trans. So, down how many carbons are there? Green is the carbons and yellow is the, yes, that is the matter. So, here 4 carbons and 8 hydrogen. So, this is the structure of cis and trans of 2-butene. So, this is the, so friends, here you sure what? Okay, she changed to one structure to another structure. What? Cis changed to trans trans change to 6 and 2 butane converts to 1 butane, 2 butane converts to 2 methyl propane. So what is the use of that? You can have any use that? Yes. So first we can see the physical properties of geometrical isomerism. So here trans isomerism has the higher melting point, cis isomerism has the higher boiling points. Means here we can observe one thing, what? That is the trans have the same, means that is the trans is the higher melting point, means automatically lower boiling point. Catch my point? Okay friends, here which is the opposite side is called cis and which is the same side all called trans. So here this is the physical property of geometrical isomerism, what? Trans isomers have the higher melting point, automatically boiling point is lower. So down cis isomers have the higher boiling point, means automatically what? Yes, melting point is lower. So this is the physical properties. So friends, you can use butane as a fuel. You know one thing? Yes, the butane is most important in our daily life also. We use the butane as a fuel. So this is the structure of fuels. Are you following me? So this is the structure of fuel, butane, we can use the fuel. So next 2-methyl propane. So uses of 2-methyl propane. But we can use the already, okay, generally in the chemical compounds in your home. So that is used to what? Yes, the solvent. So friends, already you should. So we can use the solvent. So with the including of water. So friends, here you can observe one thing, not only 2-methyl propane used in our daily life, automatically 1,2-dichloroethane also used in our daily life. So what's friends? Yes, they are the rich and we want to go any receptions and we want to go any marriages, means first we think the spray. Exactly right now. So that is the catch my point. So here we want to go any marriages, means that automatically we get the spray. So you can don't think what is, how can there is the change to and how, what, which type of gases, which types of structures they want to prepare that. Yes, here the 1,2-dichloroethane is the most important in our daily life. So let me see uses of 1,2-dichloroethane. So here the tables and automobile parts and house bearings, some lot of uses are there. So these structures of uses in 1,2-dichloroethane. Okay friends, are you sure? Okay. So next, pipes. What is the full form of PVC friends? So 1,2-dichloroethane mainly important and product to PVC also. It's right friends, means PVC is the nothing but polyvinyl chloride. So this is important to production and make to different types to called as PVC pipes. Not only PVC pipes, automatically it is to automobile parts and house wires and the lot of uses are in these PVC pipes. So here the 1,2-dichloroethane is used to in our daily life also. So friends, here the last one is this is the PVC pipes. Okay, observe friends, PVC is nothing but polyvinyl chloride. So here we can use the automobile aliphates. So next, here the stability. So what is stability? Those isomers which have the smaller value and heat converts to or mole. They have the mustard store then the resource trans to the stable cis because low value of came from molecule mole. Because friends here the cis isomers are stronger than the trans. How? In the cis, that is the structure of, for example, 2-methyl 1,2-dichloroethane. So what? Cl one side and hydrogen one side. So this is the U-like structure now. So this is stronger than trans isomerism because here this is the U shape and they have the same connectivity to cis. But here trans means we can get the down. So here the cis is the nothing but that is the U shaped and that have the stronger than trans. Okay friends, are you following me Cyrus? Okay. So here last one. So friends, this is the last one, what? Optical isomerism. So what is the definition of optical isomerism? Optical isomerism differ by the placement of different substances around one or more atoms in molecule, different arrangement of these. Substances can be impossible to superimpose. These are optical isomers. Okay friends? Okay, you can come. For example, images. We take the mirror and we show our right hand means that reflect to left hand. So you can show the left hand means that